In this video, we'll be solving a rational inequality. A rational inequality is an inequality involving fractions. So what I'm going to do is show you the steps for solving a rational inequality on this left side, and then I'll perform the step over here on the right side using this inequality. So our first step is to rewrite the inequality, if necessary, so that 0 is on one side and there is a single fraction on the other side. So I first need to get a 0. I'll subtract 4 from both sides. And these will cancel. And so I have 3x plus 1 over 2x minus 3. Subtract 4, and that'll be less than 0. But then I also need a single fraction on the other side. I've got my 0, but I need to put these two terms together into a single fraction. So right now this is 4 over 1. I need a common denominator, so I'll multiply top and bottom by 2x minus 3 to get my common denominator. So in the bottom, I have 2x minus 3. In the top, I have 3x plus 1. And then I need to distribute this negative 4. Negative 4 times 2x is negative 8x. And negative 4 times negative 3 is positive 12. And that's less than 0. Right, let's combine like terms. I have a 3x minus 8x. And that is a negative 5x. And then I have 1 and 12, so plus 13. And that's less than 0. Our next step is to solve for values which cause the numerator or the denominator to equal 0. These values determine the intervals. So I first need my numerator, negative 5x plus 13 equals 0. Subtract 13 from both sides. These will cancel, and I have negative 5x equals negative 13. Divide both sides by negative 5. These will cancel, and x is equal to a positive 13/5, which is 2 3/5. Then we also need to get the value that'll cause the denominator equal to 0. So 2x minus 3 equals 0. Add 3 to both sides. These will cancel. 2x is equal to 3. Divide both sides by 2. And these will cancel. And x is equal to 3/2, which is also 1 1/2. Right, then use a test value for each interval to determine which intervals form the solution set. So we have these two values that will determine the intervals. Let me just draw a number line here. 1 1/2 is less than 2 3/5, so I need to put that point over here, and then 2 3/5 will be here. Now my intervals, I have the interval, all the numbers that are less than 1 1/2. Then I have the numbers that are between 1 1/2 and 2 3/5. And then I have the numbers that are greater than 2 3/5. Those are my three intervals. And I need to use a test value from each interval, which means I'm going to just pick any number that's in this interval. So numbers that are less than 1.5, I can pick 0 and use that one. Between 1.5 and 2 3/5, let me use 2. And then numbers that are bigger than 2 3/5, let me use 3 for my test value in this interval. Alright, so let me test my 0 in this interval. My original inequality, 3x plus 1 over 2x minus 3 is less than 4. I'll write this here so I don't have to keep moving my paper. So 3x plus 1 over 2x minus 3 is less than 4. And for this interval, then, I have a test value of 0, so I'll just stick that in there. 3 times 0 plus 1 over 2 times 0 minus 3, and I want to know if that's less than 4. Well, 0 plus 1 is 1 over 0 minus 3 is negative 3, and that is less than 4. So this is a true statement. This interval works from negative infinity to 1.5. Then let's put 2 in. And it doesn't matter what your test value is as long as it's in that interval, because all of the numbers in that interval will perform the same way. So I'm putting 2 in. 3 times 2 plus 1 over 2 times 2 minus 3. I want to know if that's less than 4. So 6 plus 1 is 7 over 4 minus 3 is 1. So this one is not less than 4. So this is a no. And then test value of 3. We have 3 times 3 plus 1 over 2 times 3 minus 3. And I want to know if that's less than 4. So 3 times 3 is 9, plus 1 is 10. And 2 times 3 is 6, minus 3 is 3. This is 3 1/3, which is less than 4. So that one's yes. So our solution set then, we can write that in a number of different ways. If you're asked to graph it, we would need the number line, and we would need 1.5 and 2 3/5. And our solution looks like the interval from negative infinity to 1.5. And the interval from 2 3/5 to infinity. Now notice I'm not putting my parentheses or my brackets on yet because I need to check. Since this inequality is strictly less than, I wouldn't have a need for a squared off bracket in either one of these spots. So I have parentheses on both. So this is the graph. The interval notation would be from negative infinity to 1.5. Union with 2 3/5 to a positive infinity. And then the set notation, we want all numbers that are less than 1.5. So the set of all x's such that x is less than 1.5, or x is greater than 2 3/5.